And the function that I have, I want to find the volume using the shell method, and my function is y equals 4 minus x squared and y equals 0. So I want to find the volume of the solid that would be formed if I revolved this shape around the y-axis. Okay, so I'm going to revolve around the y-axis. Okay, and this is just a different method. So the first thing that we do, what do we always do whether we're finding areas or volumes? We have to draw a picture. Okay, so we need to get a picture of this area. Graphing calculator's fine. I know that this is a parabola that opens down, and I know that its vertex is at the ordered pair. Does anyone know where the vertex is? Yep. Are you going to tell me, or are you just going to say, yep, I know? It's not a 2. The vertex is not a 2. A vertex is an ordered pair. It is at 0, 4. The vertex is at 0, 4. Okay, there's a lot of different ways to find the vertex. I don't know if you remember standard form of a parabola. Y equals a times x minus h squared plus k. That's the standard form of a parabola. If I rearrange this, my a is -1. The negative x squared is basically, that's the x is all by itself in parentheses, and then that would, k would be +4. And the vertex is always h comma k, so the vertex would be 0, 4. And you know it's going to open down because of that negative. So now I'm just going to pick some other values to the left and right of 0, -1, 1, -2, and 2, and I can sketch that graph. There's my vertex at 0, 4. And then if I put 1 in here, I get -1 and 1, I get 3. So, and then if I put 2 in here and -2, I'm going to get 0. So it looks like this. It works out nice. I've got, then the y equals 0 is down here. So this is y equals 0, and this is my parabola. So there is my area right here, and I'm going to shade this in. Now, here's where it gets different for finding the volume using the shell method. The idea of the shell method is basically whatever axis you're going to revolve it around, you deal with the opposite variable. Because instead of taking disks, what we did before in the disk method, I'm going to move this, and I'm going to sketch similar. Okay, if we were finding the area of this using the disk method, okay, the disk method, then I would have, if I'm revolving it around the y-axis, this is my axis of revolution. If I'm revolving this around the y-axis, I would draw my disk perpendicular to my axis of revolution. And I'd basically be finding the area of these little things right here, all these little disks, and I'm adding up all of their volumes. Okay, and that's the disk method. The little, I'm finding it's perpendicular to the axis of rotation. Okay, but with the shell method, that same area is found using little, they're actually shells. If you think of them as little cans, and they kind of have pictures in your book, of basically on the bottom of page 467, you're finding the volume. So if I'm going to revolve it around the y-axis here, here's my axis of revolution. Instead of drawing the little bar perpendicular to the axis of revolution, I'm going to draw it parallel to the axis of revolution. And what I'm going to do now with this bar is I'm going to revolve this around the y-axis, and it's going to create like a can, or it's like taking It's like taking papers. Like if I took this paper, that's what, if I revolve that little strip around my axis of revolution, that's the shape that I get. And then if I do it again, I just keep stacking up all of these shells, and eventually I'm going to get a volume. Now, all of these shells have a height that is determined by your functions. The height of these shells is determined by the functions. And the radius, the distance from your axis of revolution, is determined by kind of the limits of integration. So the formula that we're going to use for the shell method, these are on the top of page 468 in your book. We'll come back and we'll finish the problem, don't worry about it. So the formula is the shell method for volume if we have a horizontal axis of revolution, in other words, x-axis, if we have a horizontal axis of revolution, our volume is equal to 2 pi times the integral from c to d of p of y times h of y dy. Now, p of y is the distance from the axis of rotation to the cylinder, and h of y is the height of the shell, the height of that bar that you draw. So this is the height, and this is the distance from the axis. Now, here's what you should notice. I'm revolving around the x-axis, and what is my variable in my integral? Y. And my limits of integration are y's. C and D means y values. This is the opposite. The shell method, if you're revolving around the x-axis, you're using all y values. So if there is a vertical axis of revolution, or y, then your volume is 2 pi times the integral from a to b of p of x times h of x dx. All right, so let's go back to the problem that we were looking at, and we wanted to revolve this shape around the y-axis, and our shell is going to look like, if we're going to revolve it around here, this is the axis of revolution. You need to draw the shell parallel to the axis of revolution. So here it is. Now, tell me about revolving this whole thing around the y-axis. Is it necessary to revolve that entire shape around the y-axis? No. Can you visualize what happens? I mean, if I'm revolving this whole shape around the y-axis, what would I need to do? How far would if I took this whole shape and revolved it, how far would I actually have to revolve it to get a solid? Halfway, 180 degrees. Okay? So now, I want to try to make a connection here. In this formula, what do you suppose the 2 pi is for? What's 2 pi? Isn't it a full rotation all the way around? Okay, so a way that I could deal with this full shape, instead of multiplying my integral by 2 pi, could I multiply it by? Pi. Or the other option is, couldn't I just revolve half of it all the way around? Okay, so either one of those will take that into account. You have to be aware of that. You don't need to revolve this whole thing all the way around. You can either revolve the whole thing halfway around or take half of it and revolve it all the way around. So I'm going to actually just take half of it and I'm going to revolve it all the way around. So when I set up my integral, it's going to be the integral 2 pi times the integral. Now what I need to figure out is, what is my p of x? How far away am I from, how far, see now this shell, basically you're making a whole bunch of these little shells and you're rotating them around, and the height of these shells is always different. Okay, so the height is sometimes the easiest thing to figure out. The height of the shell in this case is determined by that function. Okay, so the height is 4 minus x squared. So that's the 4 minus x squared is the h of x. So h of x is 4 minus x squared. That's the height. The distance that that shell is from the axis of rotation, the p of x, that's one that takes a little bit of work. Most of the time, if it is touching, if the shells or the area is touching the axis of rotation, the p of x will just be x. Okay, whatever these are all x values. All of these shells are located at different x values away from the center, the axis of rotation. So your p of x, your distance from the axis of rotation, will in most cases just be x. Unless you have two functions, then the distance, you have to subtract the functions. So then you just multiply by x, and now we just need to integrate that. And at this point, once you've set it up, do you have to do all this by hand? No, you don't. I would type this into my calculator.
Please pardon this interruption. At this time, band students need to head to the band room. Band students to the band room. Thank you.
So I guess one thing, what haven't we figured out here yet? The limit. So where does this area start? 0 to 2. And then you would integrate this. The final answer, if you do it on your calculator or by hand, you should get 8 pi. So I know the assembly is, we're going to be heading up there pretty soon. So I just wanted to introduce you to this and give you a very small assignment. Page 472. Problems 2, 4, 6, 14, and 18. Two, 4, 6, 14, and 18.